Hello, welcome everyone. So please subscribe the channel so that you will get the notifications whenever I will upload the videos regarding the subjects or any point, and do share with your friends so that they could get more knowledge about the subject and about the topics. So let us start here. In this video, you're going to see thermodynamics introduction. So thermodynamics is a branch of a science which deals with the energies and possessed by energies possessed by the gas and the vapors. So it is one of the branch that is dealing with the uh, energies which is generated by the gas and vapors. So energy means fuel. The whatever energy it is generated by the fuel or by other source where it deals with the particular things. So now let us start with this subject. So here, first of all, you need to understand some terminologies, some definitions. So those definitions are like volume, pressure, and temperature, or else mass, pressure, temperature, absolute temperature, normal temperature, and pressure. So these are the important terms what you need to remember, because in the upcoming chapters, upcoming topics, you may come in contact with these terminologies. So where you need to understand these definitions here only. So what is meant by volume? First of all, let us understand. So volume means volume is a space occupied by the substance. It is measured in a cubic meter. So if I take a glass, so if in the glass there is a water, if I consider it, so whatever the water it is available in the glass, it can be said as this is the amount of volume or else space that has been occupied by this water. If I consider full of glass, then we can say this much is the space of the total space that is available in this glass, we can say. So the similar way, if there is an hall or else cylinder, any kind of object, if you take the whatever the space it is there, whatever internal space it is there, uh, area, we can call it as a space. Okay, that space is called as a volume. So the unit of this one is the meter cube. So how we are measuring that unit? If I take a glass or a box, suppose if I take a box, so this is the box. So whatever the space that is available inside this box is the volume of this box. So how to give that volume? Volume is represented with the help of V. Remember it. Now here you have to take length, width, and height. So this is L, this is width, and this is height. So length into width into height. If you multiply, you will get the volume of that box. So here in the similar manner, you are multiplying this length in meter and width in meter and height in the meter. So that way it becomes meter cube. Or else this is one method. So if you are measuring it in the centimeter, then it will be centimeter. If you are measuring in the centimeter, it will be centimeter cube. Or else if you are measuring in the inches, inch cube, it will be inch cube, you can say. Okay, usually we take in the meter cube, centimeter cube. So you will refer this SI units only for the upcoming problems and all. So remember, what is volume? It is a space that is occupied by the substance. It is measured in the meter cube. Then next comes the pressure. Pressure is a force exerted per unit area. Here, if I take an object, if something on table or else something, if I take, so if I apply the force here on this surface, so this force, whatever it is applied on the particular area, then it will be distributed on that area. Is it right? If I take a point force, then it will be at the point only. But if I take the certain area, so here with the uh, different force whatever it is acting, so then we can, it will be completely distributed on particular area, so that whatever force it is applied and it is on the particular area, then this force applied per unit area is called as a pressure. Okay, so pressure is measured in the Pascal, the force is measured in the Newton, and area is measured in the meter square. So here Pascal is the unit of pressure, or else other unit you can say. So force upon area it is. So area force is measured in the Newton, and square, sorry, meter square it is. So you can say pressure is, other unit of the pressure is Newton per meter square. So what is the relation between the pressure Pascal and Newton per meter square? So if I write 1 Newton, sorry, Pascal is equal to 10 raised to 5 Newton per meter square. So remember it, 1 Pascal is equal to 10 raised to 5 Newton per meter square. So next is the temperature. Temperature is the measure of the degree of hotness. It is how how much hot the temperature is there. Usually you know about it, but it is defined as, it is the degree of hotness or a coldness of a body. We can say we are measuring this one in terms of the degree Celsius. Usually we measure it, but when uh, if in the thermodynamics, sometimes you will refer it to the absolute temperature measured from the absolute zero. It is called as absolute temperature. So how you will be representing that one in the Kelvin. So whatever the degrees Celsius temperature you have got, we have to add 273.15 for it. So then we'll get in terms of the Kelvin. Suppose if I add 20 plus 273.15, it will be 293.15 degree Kelvin. So this is in terms of 20 is in terms of degree Celsius. But if I want to make it as absolute temperature, measure it as an absolute temperature, then we have to add plus 273. Then next comes here the heat. So heat is the form of energy, one of the form of energy. It is transferred due to the temperature. Always heat will be flowing from the higher temperature to the lower temperature. So consider if I am having a cup, okay, and this cup is having hot tea, hot tea. If the cup is having, then the if we keep this cup of a tea in the atmosphere for some times, then the hotness, whatever it is hot, if it is there, it will become cold automatically after some times. So what it means, the heat whatever it is there, it will flow from the higher temperature to the lower temperature. Whatever the heat is there, it will flow to the atmosphere, because atmosphere temperature will be lower here, and the temperature of the tea will be more. So it will try to make the equal temperature equilibrium. It is trying to come at the equilibrium, means the atmosphere temperature and the temperature of the cup will always try to what, come at the same temperature. Okay, so one thing we have to remember here, the heat is the form of energy. It is transferred from higher temperature to the lower temperature. Then it is represented by the joule. The unit of the heat is joule. Then next, specific heat. Specific heat is the amount of heat it is required to raise the temperature of a 1 kg of substance by 1 degree Celsius. If I take something, some object, or else something, some liquid, something, uh, and if I want to rise the temperature of this 1 kg substance, if it is the 1 kg substance, if it is, so it is 1 kg substance, and I want to rise 1 degree Celsius or a 1 Kelvin. If I want to rise the temperature of this one, of a 1 kg substance through 1 degree Celsius, The amount of heat that is required means when you want to increase the temperature, then always you will need the heat, because adding of heat only can increase the temperature. Without adding the heat, you cannot increase the temperature. So here, to in order to increase the temperature, you need to add the heat for it. And for 1 kg substance, when you will raise the 1 degree Celsius, the amount of heat whatever it is required, it is called as a specific heat. It is the specific heat. So the unit of this one is joule per kg Kelvin, because uh, whatever heat it is there required, it is measured in the joule. So per kg, because we are considering only 1 kg and 1 degree Celsius. 1 kg and 1 degree Celsius. That's why we call it as a per kg Kelvin. Heat required to raise the temperature of a 1 kg of a substance through 1 degree Kelvin is called as the specific heat. So many times you will going to come across this specific heat. So remember it. So these are the basic terminologies what you need to remember. Apart from this, you are having the work that is measured in the work also is there one term. Let me mention here. So work is there. So work is it is the product of the force into a distance. Usually, what we give W F into X. Okay. Here, uh, the unit of this one is Newton meter. What we take. Then specific heat is there. So already we have studied about the heat. We have studied about the heat here. So this is in general what we give, specific heat. Okay, that is C. But when you want to mention the specific heat of at a constant volume, that is called as the CV. It is the what S- specific heat at constant volume. And CP, if you mention this CP, then it is called as a specific heat at a constant pressure. Specific heat at constant temperature. So sorry, pressure. It is at the pressure. Okay, CP and CV are two terms. Are the different two terms. Only what you have to understand is here. CP is the constant volume and at the constant pressure. Okay, so same terminology will be there. Specific heat of amount is required. Here you need to add one word, add pressure, constant pressure to raise the temperature of 1 kg of a substance through 1 degree Celsius. Then it is called as specific heat at a constant pressure. And if I say specific heat of specific heat at the constant volume, then the amount of heat required to raise the temperature of 1 kg of a substance by 1 degree Celsius at constant volume, then it is a specific heat at a constant volume, CV, that is CP and CV. I hope you have understood one CP and a CV what it is there. So the whatever the values are there, see specific heat at a constant temperature and pressure will be given into the problems. So you have to consider that while solving the problems. Then next comes here, universal gas constant, that is R. Universal gas constant R it is. So that is always given in terms of the R, and it is 8.314 joule per mole kg, or else you can write it as mole kg or kg mole Kelvin. You can write 81 sorry 831 4 joule per kg mole Kelvin, mole Kelvin, or else we can write it as a 8.31 kilojoule. It is a kilojoule. So here it is wrong. It has been mentioned kilojoule per kg mole Kelvin. So 8.314. When you are writing, you have to write it in the kilojoule. Means uh, you have to divide it here by the thousand. You have to divide here with by the thousand. So whatever it is there, 8314 divided by thousand when you do, so it will become 8.314. So this is a kilojoule. So whatever the joule was there, we will mention it now as a kilojoule per kg mole Kelvin. Okay, this way you can mention it also. Then comes here a perfect gas or an ideal gas. We can call it as may be defined as the state of a substance whose evaporation from its liquid state is complete and strictly obeys all the gas laws under all conditions and the temperature conditions of the temperature and the pressure. Whenever the gas is obeying all the gas laws under the specific conditions, uh, it has completed its whose evaporation from its liquid state is completed and it is in perfectly the liquid will be in the gaseous form and obeys the all gas conditions, then it is called as a perfect gas, we can call it as. So the next after this there are gas laws. Generally these are Boyle's law, Charles law and Gay-Lussac's law are the three laws that are the gas laws you are going to see here. So this will be we will see in the next video. Please follow the next video. Whatever it is there, we'll get about the gas laws. Thank you for watching the video.